Today we're talking about chapter 6.10, which is the second to last chapter of chapter 6. So actually, we're almost at the end of chapter 6, so you should be ready for your test actually, but we're going to do some more practice with fractions next week before we get ready for our test, okay? So lesson 6.10 is all about problem solving, using what you know about fractions, about adding and subtracting fractions and mixed numbers and patterns with fractions, using all of that knowledge and those skills you have to solve word problems. Okay? And I love word problems because that takes math out of the math book and into a real world context, right? It shows you how these fractions might be used in real life. Okay? And today we're actually going to focus, we're going to use our lens, and we're going to focus specifically on one strategy, and that strategy is to work backwards. Okay, so in all of our problems today, we're going to be looking at how we can work backwards to solve the problem. But first, let's talk about the problem of the day. The Diaz family is cross-country skiing the Big Tree Trails, okay, which have a total length of 4 miles. How long altogether is this trail that they're skiing? 4 miles. Yesterday, they skied the 7/10 mile Oak Trail. So they skied the Oak Trail yesterday, which is 7/10 of a mile long. Today, they skied the 3/5 mile Pine Trail. So they skied the Pine Trail today and the Oak Trail yesterday. Okay? If they plan to ski all of the Big Tree Trails, how many more miles do they have left to ski? Now, I see words and I see a math problem. So Marcus, what is the question asking us to do or to find?
How many more miles do they have left to ski?
We need to figure out how many more miles out of those 4 miles that they have left to ski. What's the important information that we need in order to solve this problem? Siddharth?
Yesterday they skied 7/10 miles. Today they skied 3/5 miles.
Okay. Chica?
They plan to ski the rest of the trail.
Well, right, we did say that they're gonna ski the rest, but there's some important information we're leaving out that we haven't identified. Yarden? Right, altogether they have 4 miles that they need to ski. So step 1, and I want you to write this in your notebook. Step 1, Marcus and Ashi, please stop playing with your pencils and write good math notes. Step 1, write an equation. Okay? So we're going to write an equation that's going to have our total answer be our total distance. So how many miles did they ski yesterday? How many miles did the Diaz family ski yesterday? Ashi?
7/10
Okay, they skied 7/10 of a mile yesterday. How long did they ski today? What distance did they ski today? Ariel? 3/5 of a mile. And then we're going to write a variable because we don't know yet the amount that they still have left to ski. And so M stands for miles. So why don't we say M equals the amount of miles that they still need to ski. If I do 7/10 plus 3/5 plus M, that should equal the total distance that they're going to ski, which is how many miles? 4. So in your notebook right now is please write step 2. Work backwards to find M. How could I use my addition equation to work backwards? What could I do, Liam?
Well, you could write another equation. So 4 minus the whole entire distance they need to ski.
The total distance, which is 4.
Minus in parentheses 7/10 of a mile, which is 1 trail, and
The total distance of 4, and subtract the amount that they have already skied. 4 minus 7/10 minus 3/10, or 3/5, sorry, and that should give me the total amount that they still need to ski. Why can I use subtraction when I'm working backwards to figure out an addition equation? Sarah?
because it's inverse operation.
Addition and subtraction are inverse operations, meaning if I'm adding, I can undo the addition by using what? Subtraction. So I can take my total amount right here and subtract the amounts that they have already skied in order to find out the amount that they still have left to ski. Okay, am I ready to subtract?
No.
Why am I not yet ready? I mean, it's the inverse operation. How come I'm not yet ready to subtract? Arushi?
So 4, you have to rename 4 into 3 and 10 tenths so that you you can subtract 7.
Okay. Okay, so I'm going to rename 4 into 3 and 10 tenths, and then I can subtract 7 tenths. When I do that, what do I have left? How much do I have left? Let's subtract the fractions first. 10 tenths, and if I take away 7 of them, how many tenths do I have left? 3 tenths, okay. And then if I have 3 and I take away 0 wholes, how many do I have left? 3. Okay, so now I've finished this part of the equation, and I still have to do 3 and 3 tenths minus what? 3 fifths. Am I ready to subtract?
No.
Why not? Ariel?
You need to make it into 16.
I need to make sure I write it using, I need to write an equivalent fraction that has the same denominator. Okay, can I do 3 tenths minus 6 tenths?
No.
What do I need to do?
You need to make 3 tenths into 2 and 13 tenths.
2 and 13 tenths minus 6 tenths. All right, if I have 13 tenths and I take away 6 of them, how many tenths do I have left, Colin?
You have 7 tenths.
7 tenths left. And then if I have 2 and I don't take away any more holes, how many holes do I still have left? 2. So how many more miles does the Diaz family still need to ski? Karan? And so my final answer is 2 and 7 tenths miles.